Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about why sometimes we need less machine learning models. This topic is based on a tech blog with the title One Model to Serve Them All, written by the machine learning team from Instacart. You can find the link to the blog in this episode's description. Throughout this episode, we'll dissect the topic from both business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Instacart is an online grocery delivery service that enables users to shop at nearby stores for delivery or pickup. They have their advertising business representing a growing business unit. In 2022, Instacart reported a revenue of $2.5 billion, with $740 million, which is about 28% of the total revenue, derived from their advertising business. The advertising service requires to make prediction on how likely a served advertising impression would lead to a click activity. To make this scalable, it is necessary to have a machine learning model that can predict the click-through rate when ads were served on a product surface. Throughout the company's expansion, there are a lot of different page layouts being created, each tailored to provide a distinct user experience. Those multiple surfaces are for purpose of displaying goods, and placing sponsored product on each surfaces result in different performance. This is usually influenced by the different surface's contextual nature. For example, when a customer is on the main store page, viewing myriads of the products, they may be more inclined to click on ad featuring something new from a household brand. Well, when a customer is on the Buy It Again page, they are likely to click on ads similar to what they have been purchased before. As you can see, the likelihood of clicking on the ad varies due to the context nature. And this is the reason that the team develops different machine learning models based on different pages' historical data. Over time, there are more than 5 machine learning models being created to make the same click-through prediction, just on slightly different product surfaces. Now we understand the business context. Let's take a closer look at the issue with this one machine learning model for each product surface approach to see what is the problem. There are a few challenges the team observed associated with their current implementation of the different machine learning models. Some are originating from the fact that previous machine learning solutions were based on gradient boosting tree model. Well, if we focus only on those arising from the single model, single surface nature, two primary challenges emerge. The first challenge is that for each of the individual machine learning model, a separate training dataset is required. And this separation in training datasets across different models makes the cross-sharing of user interaction insights impossible. For instance, if a user displays interest in a specific product on one product surface by interacting with them. This engagement data could not be propagated to other surfaces when constructing the training data for other click-through models. The second challenge revolves around maintenance complexity. Deploying a machine learning model for each surface introduces significantly operational complexities. The effort involved in managing the service, monitoring the service, and the incident response for both the data pipelines and the model serving grows linearly with the number of surfaces available. In addition, any future improvements or changes are hindered by the complexity of orchestrating changes with full cross-functional stakeholders. To overcome these challenges, the team embarked on a journey to develop a unified browse click-through rate prediction model, where the overall direction focuses on developing a deep learning model to unify all the click-through rate prediction needs and across all the product surfaces. This unified model involves two major changes comparing with the status quo. The first change pertains to the dataset. The team combines the training data for each of the product surfaces, resulting in a richer dataset capable of training more sophisticated models. The second change addresses from the deep learning architecture. The deep learning architecture provides a direct advantage in incorporating high cardinality features, such as user IDs, product IDs, through the use of the embeddings. It also offers the flexibility to adopt advanced deep learning state-of-the-art technologies. Within this deep learning architecture, on the feature side, the team prepared various features from user side, product side, and contextual natures from the interface. And on the architecture side, the team leverages a commonly used wide and deep architecture in the deep learning approach. With these significant changes, the teams tested out the model's performance through A/B testing. On one side, they use this single unified model to serve the click-through prediction over all product surfaces. On the other side, it was compared with using each individual machine learning model to serve the CTR prediction on different surfaces. Through this experimentation, they discovered that the unified model performs overwhelmingly better than the previously scattered serving approaches. This marks an exciting progress made. Furthermore, with all the 5 models being unified, machine learning iterations become much more streamlined and efficient. Later on, the team incorporated real-time features and directly launched a better version of this unified model the right following week. This is a task that would have been impossible if the needed change has to happen over all 5 different models. Now we discussed both the business problem and technical solution. Let's wrap it up. In this episode, we discussed the business context of Instacart's advertising business and the challenges posed by their previously scattered machine learning model solution. We also shared how they unified their click-through rate prediction model by leveraging an advanced deep learning architecture. If you like the content of this episode, please subscribe to the channel, give me a 5-star review, and leave a comment. Your feedback is very appreciated, and I'll see you next week.